Here is a data set that you can find in the list of data sets from StatCrunch. And in this data set, we can see the variables are gender, so we have males and females, part-time, full-time student, so whether or not they go to school part-time or full-time, whether or not they work, and if they do, is it part-time or full-time, the amount of time then that they spend studying, and that's in hours. And then we have a GPA, what their corresponding GPA is. So the natural question is, how much does the amount of time that you study affect your GPA? Or does it? And can we quantify that relationship? So let's click Graph, Scatter Plot. Probably want to make study time our X variable because we're thinking that study time probably affects GPA. Click Compute. And we look at this scatter plot and we see that maybe we have some sort of a linear relationship here. I don't know. It's pretty scattered. But let's check it out by looking at the fitted line graph and the residual plot. So we'll click Stat, Regression, Simple Linear, Study Time, GPA, and then let's come down here and click Plot the Fitted Line and Residuals versus X values. Click Compute, and we see our R coefficient is 0.432. One thing that is interesting to note is the size of the sample. There are 35 subjects in the sample. So here we appear to have maybe a linear relationship. It does appear that maybe as X goes up, Y goes up, or in other words, as study time goes up, so does GPA go up. And looking at our residual plot, it does look like we have a random distribution above and below the line Y equals 0. Let's take a look then at this relationship. We can see then that our relationship is the predicted GPA value we can find by going, and let's go to maybe 3 decimal places here, 2.215 plus 0.049 times the study time. Our slope coefficient is 0.049. We would interpret that slope coefficient by saying for each additional hour of study time, we can expect GPA to increase by 0.049 points. Whether or not we can make this statement actually depends on the significance of the model. A bit later in the course, we will learn how to test that.